Welcome everyone. What we're going to do now is an example of applications of integration where we find the area bound between two different curves. And so if we look at the problem here, it says to find the area of the region bounded by the curves sine x and cosine x for values of x in between x equals 0 and x equals pi divided by 2. So if you look at the graph to the left, you'll see that sine x and cosine x sort of intersect each other right in the middle there of the closed interval of x values, which is at x equals pi over 4. In degrees, that's 45 degrees, and pi over 2 is 90 degrees, in case you're wondering about that. So here we want to find basically areas A1 and A2, okay? And so in order to do that, what we do to define the area bounded by those curves is we know that the integral is the area under the curve for a function anyway, so we just take the difference of that. But the important thing here is that we take the absolute value of the difference of both of those curves. The reason why we need to do that is because we want to make sure that we don't get any negative values. So there are times when one curve may have greater y values than the other, and then it may switch off. And so we need to identify if and when that happens within a closed interval. This particular example actually does that. So that's one of the reasons why I'm doing this particular example for us now. So if we look, cosine x is the green function and sine x is the red function. And we see that cosine x is going to be greater than or have larger y values than sine of x up until when x equals pi over 4. And then at that point it switches off and sine x is greater than cosine x. So because of that, when we write out our integral here to do the area, we're going to have to break it up in two pieces. For x equals 0 to x equals pi over 4, we will have cosine being greater than sine, so we'll write cosine first. So we'll let cosine be in the f of x place and sine of x be in the g of x place. However, from x equals pi over 4 to x equals pi over 2, we will let sine x be in the f of x place and g of x be, let cosine of x be where g of x is. Okay? All right, so let's go ahead and get started here. So we want to write function here, area is equal to the integral. And since we're integrating from x equals 0 to x equals pi over 2, we want to do absolute value of, here we'll just write cosine x minus sine x then dx. Now, just as we discussed before, we need to break this integral up into two different pieces. So there needs to be a part for x equals 0 to x equals pi over 4, and there needs to be another part for x equals pi over 4 to x equals pi over 2. So let me correct that. And so here pi over 4, not quite working out well for me here. Let's try again. Pi over 4 and pi over 2. All right, and so in this first one here, we're going, since cosine is greater than sine, we're going to say cosine of x minus sine of x. All that enclosed there, dx plus, and then here we're going to switch it and say sine of x minus cosine of x dx. All right, and so now it's just a matter of doing the integration here. So we know for cosine that cosine is a derivative of sine. And so in that case, we know that when we do the integral of cosine, it is just sine. Similarly, we know that for minus sine, we know that the integral of minus sine is cosine, because we know that the derivative of cosine is minus sine. So in doing that, we're just going to go ahead and write out the integrals now. Okay, so here we know that this is going to be sine x, and this will be minus a negative cosine x, and this will all be evaluated from 0 to pi over 4. And then for this portion, we'll evaluate that from pi over 4 to pi over 2. And so for sine, we know that the integral, or the antiderivative of that, is minus cosine. And for cosine, the antiderivative of that is sine. And we'll evaluate that from pi over 4 to pi over 2. And so when we do that, we end up with the following here. So we have sine of pi over 4 minus sine of pi over 4 plus cosine of pi over 4, and then that will be minus, and then if we plug in the zeros here for this portion of it, sine of 0 is 0, and cosine of 0 is 1. Then we come here and do the second part. So now we have minus cosine of pi over 2 minus sine of pi over 2. And then we need to subtract, and that would be minus negative cosine pi over 4 minus sine of pi over 4. And that's the second part. And so now once we're done with all of that here, we'll see that sine of pi over 4 is just 1 over square root of 2. Cosine of pi over 4 is just going to be cosine of pi over 4 here will just be 1 over square root of 2 again. And of course this part here is just 1. Cosine of pi over 2 is just 0. Sine of pi over 2 is just 1. And cosine pi over 4, 1 over square root of 2. Sine of pi over 4 is 1 over square root of 2. And so if we write all this out, we end up getting 1 over square root of 2, and that's 2 of those, so we'll just go ahead and say that that's 2, and then that's minus 1. Then we have plus a, let's see, we have a negative 1 there. And then it looks like we have a square root of 1 over square root of 2 plus another square root of 2. So it looks like we got 2 of these again. So that would end up being 2 of these, and that would be, so we got 4 over square root of 2 minus 2. And if we simplify the 4 over square root of 2, it'll just end up giving us 2 root 2. And so this would be in square units. So to repeat here, we had function, or 2 functions here, and we wanted to know the area bounded in between them, in between x equals 0 to x equals pi over 2. We use the formula where we take the integral of the difference of both of those functions, take the absolute value of it, and evaluate it from a to b, where our a in this case is 0, and our b in this case is pi over 2. And so we notice that since what's greater than and less than switches off, we want to make sure that we write it properly and break up the integral. So that's what we do for the first part. We break it up from 0 to pi over 4, letting cosine be the greater function, and then from pi over 4 to pi over 2, letting sine be the greater function. And then after that, we evaluate the integrals, figure out what the trigonometric functions are, evaluate for the different angles, and then afterwards we just compute our answer, and we get 2 root 2 minus 2 square units.